Today we are going to be talking about linear and nonlinear functions and what makes those two things occur. All right, so first of all, we talked a little bit last week about standard form. So standard form is when the x's and y's are on the same side. So your coefficient in x plus or minus your coefficient in y are equal to your c. An example of that would be 6x plus 3y equals 15. Okay, another thing we're going to review is a linear function. A linear function produces a straight line when graphed on the coordinate plane. It can be written in slope-intercept form, which is y equals mx plus b. Okay, the next thing is the slope-intercept form through the origin. So notice that when an ordered pair goes through the origin, which is at 0, 0, that becomes your y-intercept. And that equation is going to be y equals mx for a line going through the point 0, 0 with a slope of m. An example of that is y equals 6x. Okay, and we will get more into looking at our equations and that kind of thing. So if you notice, it doesn't have a b, and that is because it goes through the origin, which is 0, 0. So if you put a plus 0 here, you would know that this would be a linear equation that goes through the origin. All right, next thing, again, is slope-intercept form, which is an equation of y equals mx plus b. And our example is y equals 3x plus 2. All right. Initial value is where the x value is 0. This is also where the graph crosses the y-axis. This is your y-intercept. All right, so I have y equals 3x minus 2. What is the initial value of terms of an ordered pair? Okay, so this right here is my initial value. If you remember, it's where it would cross the y-axis. So that means that our x value is 0, so the first number in our ordered pair is 0. The second is going to be this initial value, or y-intercept, so it's going to be negative 2. Okay, so for the really new thing today, this is pretty new, and so is this right here, a nonlinear function. We've talked about what makes something a function and not a function before, but a nonlinear function cannot be written in the form y equals mx plus b. It just can't. Now, these equations have exponents greater than 1, include the square root of x, or x as the denominator of a fraction. They are not represented by a straight line. They are not a straight line. Okay? So your examples could be such as this. Y equals 4x to the third. That would be an exponent greater than 1. Or you could say y equals x squared. That's also an exponent greater than 1. Any number above the x is an exponent. Okay? Well, the inverse operation, or the opposite of a number being squared, is taking the square root. So y equals the square root of x is a nonlinear example. You can even throw in a plus 4 here. Even taking the cube root is also nonlinear. Sorry, this is not supposed to be there. Okay? And then the last thing would be x in the denominator. So you could have y equals 3 over x, because this is in the denominator, it's not a linear function. Which equation represents a nonlinear function? Okay, so look at these and determine which one of these are nonlinear based off of this right here. Alright, so looking at this, you should have picked a couple of these. Alright, so the first one I see is going to be A, and the reason why is we have an exponent greater than 1. Alright, going down, this is written in standard form. There's no problem with this one. This right here, y equals 15.3. This is a linear equation because it is going to cross the y-axis at 15.3. Our slope here is going to be 0, but it's still a linear equation. Okay, y equals 1/4 x minus 2. That is a beautiful equation written in slope-intercept form. Y equals 1 over x. I see x right here is in our denominator, so that makes it a non-linear function. Equals x squared plus 2. Oh, x squared plus 2 means it is nonlinear. Okay, for g, y equals 5x plus 2, and we have to distribute. You would get y equals 5x plus 10. Still a beautiful linear equation. H, y equals 2 minus x. Technically, it's not in slope-intercept form, so if we rewrite it, it would be y equals negative x plus 2. That makes it linear. And then this last one right here, I see this big old nasty square root sign. So that is going to make this a non-linear function. Looking at graphs, all right, so the word linear has the word line in it, right? So we want a straight line. Looking at these two graphs, which graph represents a non-linear function? This graph right here is a nice, beautiful straight line, so it's going to be linear. This right here has a curve in it, so therefore it is nonlinear. And what has actually happened here, we have created a parabola by squaring our x values. If you actually look right here, it says x squared. So therefore, it is nonlinear. Okay, so now we are going to look at a table to see which one is linear or nonlinear. Okay, so in order for a table to be linear, your slope must be the same throughout. So we have to look at these and determine if they are linear or nonlinear based on their slope. So as I look at this, we can look at the table and see how much they're increasing by. So as we go from here to here, I go from 1 to 2, so that's a plus 1. As I go from 2 to 3, that is also a plus 1. 3 to 4 is a plus 1. So my x's are working, right? Okay, on the bottom, as I go from this one to this one, this is going from a 1 to a 4. So we're going to add 3. The difference between 4 and 1 is 3. As I go from 4 to 9, the difference is 5. And then as I go from 9 to 16, the difference is 7. So they are not increasing by the same thing each time. So this one is going to be non-linear. And the reason why is our y's do not increase at the same rate. It's non-linear because these y's right here are not increasing by the same rate. Okay, and they could increase or decrease. It does not matter as far as that, as long as it is the same representation each time. Okay, let's look at this example right here. I go from 3 to 6, so that's a plus 3. 6 to 9, plus 3. 9 to 12, plus 3. My x's are increasing by the same. Now look here, I'm going to go down. But to go from 10 to 12, that is a minus 2. 10 to 8 is a minus 2. 8 to 6 is a minus 2. So everything is increasing at the top, and my y's are decreasing by the same. So that is going to be a linear equation because it has the same slope throughout. Now, one of the things you could do is go through and find the slope of each set of order pair. So like I could find the slope of these two, and then these two, and see that they would not be the same. Okay. So third example, I'm going to do this last one with you, and then you are going to do these other 6 by yourself. The answers will not be in the video because I want you to at least attempt this. 0 to 1 plus 1, 1 to 2 plus 1, 2 to 3 plus 1. 1 to 3 is a plus 2, 3 to 6 is a plus 3, and 6 to 10 is a plus 4. These are increasing by the same, these are not, so it is non-linear. Not the same slope. Okay, so now what you're going to do is take a moment, go through and answer these 6, and then when you get ready, go ahead and play the video again, and we're going to jump down here to looking at graphs. Actually, no, I'm not going to do the graphs with you. I think you could do that based off of what we did on the front page. We're going to jump to the back page and look at actually graphing linear equations. So take a moment, finish the rest of this page, and then go to the next page for the rest of the video. Okay, last part of this video is determining whether an equation is linear or nonlinear, but we're proving it by graphing. We may have not done graphing before, so let's figure out how to do this. First of all, let's determine if these equations are linear or non-linear. I have y equals negative 2x plus 5. Looking at this, I don't see any exponents, I don't see x in the denominator, and I don't see x with a square root symbol. So I'm going to say that this is a linear equation. And now I'm going to prove it by graphing it. So the first thing we're going to do is we are going to make ourselves a little table right here. X, Y. Okay? So it tells us in our directions to use negative 2, negative 1, 0, 1, and 2 for our x values. Notice they're the same over here, and then as you jump down, it gives you different ones as to use. So follow those directions when you go to do that. All right, so looking at this, I have the equation y equals negative 2x plus 5. What you are going to do is replace this x right here with these x values right here to figure out what your y is. Remember, x is our input. When we put it in, that is our output. So here we go. In place of x, I'm going to put negative 2. If you do not feel comfortable doing this without a calculator, please use the calculator. All right, negative 2. It's beside the x, so I'm going to replace it with negative 2 like this, plus 5. How I did that is I did y equals negative 2 times negative 2 plus 5. I replaced my x value with my x with my x value, and I got that my answer was 9. Okay? Moving on to the next one, we did negative 2 times negative 1 plus 5. Should get 7. Negative 2 times 0 plus 5 gives us 5. Negative 2 times 1 plus 5 gives us 3. Negative 2 times 2 plus 5 gives us 1. Okay, so what we have done now is created a list of ordered pairs. Most of the time when you go to create a graph, if you are not given a set of numbers to use, I would always go with this right here. This is a good set of numbers to use. Okay, so the first thing we're going to do is we're going to graph these. All right, so negative 2, 9. I'm going to go left 2, and I'm going to go up 9. I went left 2 here, and I realized the dots are small, the grid's small, and they're not numbered, so we're going to be really good math students here and do this ourselves. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's our first point. Our next one is negative 2, 7. Now, negative 1, 7, excuse me. Negative 1, 1, 2, 3, 4, 5, 6, 7. 0, 5. 1, 2, 3, 4, 5. And 3, go to the right one because it is positive 1, and then 1, 2, 3, and then 2, 1 to the right, 2, up 1. Here we go. Now, we got our points. Now we need to prove that this is a linear function by graphing it. I'm going to turn my paper here so I can make a nice straight line like so. I've done better. Okay, so there is proving that y equals negative 2x plus 5 is a linear equation. The second one we're going to look at is y equals x squared plus 2. I can look at this and see this exponent, so I know that it is going to be nonlinear because it's an exponent. So this is nonlinear. Now I have to prove it. Same thing, create your table. Negative 2, negative 1, 0, 1, 2. Now, here's the interesting thing about when we do exponents and positive negative numbers. You must include the parentheses around this x, because if you don't, it changes the whole number. Okay, so this is actually going to be y equals negative x squared plus 2. And I'll show you one on the calculator. Okay, so what we're doing, remember, is we're replacing x with our x values, our inputs, to get our output. So here we go. I'm going to do it first without parentheses. And I get negative 2. Okay, I'm going to do it with parentheses. Negative 2 squared plus 2, 6. That is what we're looking for. Okay? Because when you have a square like this, it's supposed to create a parabola. All right, and our answer is going to be 6. All right, next one. Negative 1 squared plus 2 gives us 3. Zero squared plus 2 is going to give us 2. 1 squared plus 2 gives us 3. And then 2 squared plus 2 gives us 6. All right, so now we are going to graph these to prove that this is non-linear. Negative 2, from the origin, we're going to go left 2, and then up 6. Negative 1, 3. From the origin, we're going to go left 1, up 3. 0, 2. We're just going to go up 2. 1, 3. And then 2, 6. All right, from here, we're going to create our parabola because we are squaring that x. Okay, so for the next piece down here, you are going to graph these on your own. I do want to point out that when you put this in there, so for instance, I'm going to do the first one with you. So we're replacing x with 1, 4, 9, 16, and 25. Wow, that's a really big number. I don't think it's going to fit on the graph. Well, if you notice, we're taking the square root, so it will get smaller. Okay, so our x values we're going to use are 1, 4, 9, 16, and 25. All right, so you can only graph those. That's interesting. But we'll make it work. All right, so for instance, when you do this, you're going to take second x squared, type in the 1. You have to hit the over button to make this work, okay? Because if I keep typing +1, it is all included in the square root symbol, and that's not what we want. So we got to do that, hit the over button, see how it goes away, +1, we should get 2 is our answer. Okay, you're going to keep going and then do both of these for your notes. Your homework tonight is going to continue doing that by graphing linear and nonlinear numbers using a table. So you're going to take this right here, and this is going to be your homework, and then you're going to explain to me why they are linear or nonlinear. And remember on practice 3 down here to include your parentheses around your x. Oh, how about that? It's the exact same one from your notes. So you should get that one right.